Video for the chapter 1 review, and I'm going to move extremely quickly, so make sure. I don't want to spend as much time on this, so you might just skim through this and try to find the questions that maybe you're having trouble with. First one says, what is another name? So number 1 says, what's another name for segment BJ? Segment BJ goes from here to there. Another name for that segment is segment JB, which is letter B. Number 2, what's another name for ray BJ? So ray BJ starts here, goes out through this way. Another name for that same ray would be ray BO. It's still got to have the same starting point, but the second letter doesn't have to be the same as long as it goes through it. So ray BO would be letter C. Number 3 says, figure below is a rectangular shipping box. Name 2 different planes that contain line DH. Line DH would be this line that goes through here. And we want 2 planes that contain that. Well, this front plane right here would be one of them. The side plane would be one. Remember, to name a plane, use 3 letters. It says plane ADE, so that's the front plane. Plane CGH, that's the side plane, so the answer to this one is letter A. FBC for letter B would be the back plane back here, so that's not going to work. And then you could go through the rest of them, but the answer this time happened to be A. Number 4 says, measure segment MN to the nearest 1/10 of a centimeter. Now, I sort of drew this ruler here. My ruler's not very good. Notice they didn't start at 0, but if we just count here, it's not going to be 7. We count, there's 1 whole centimeter. Looks like 2 whole centimeters. It actually looks like it comes out to exactly 2 whole centimeters, but that's not one of the options down there. So maybe it stops just a little before that, so this would be 1 whole centimeter. Then we count the spaces, 1, 2, 3, 4, 5, 6, 7, 8, about 9 spaces. So the answer should be 1.9, which is A, 1.9 centimeters. Number 4, they give us this inch ruler. We're going to measure it. Again, notice it doesn't start at 0, so we count out. We go 1 inch, 2 inches, that's going to be our whole number. Then when we get to here, we got to count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like it stops right about there, so about 12 spaces. So we got 2 and 12/16, and we can reduce that down, so it's 2 and 3/4 inches. And that's letter C on the paper. Number 6, sorry. That last one was number 5, not number 4, I think I said. Number 6, we got this segment, and we're just going to use the segment addition postulate. And we know that this segment plus this segment should equal the whole thing. So 12 plus 20, and that means AC is 32, and that's letter D. Number 7, same idea on number 7. Give us a segment, looks like this. It's A, B, and C. They tell us that this whole thing is 41. This part right here from B to C is 29, and they want us to find segment AB, which is that part. This time, instead of adding, we're going to subtract, so we just take 41 minus 29, and you get 12, and that is answer A. Answer A on the paper. Number 5, we look here, and we see these tick marks. That tells us that those 2 segments are congruent, and it tells us that this point right here is the midpoint, and it also bisects the segment. So part of our answer is point M. Point M is the segment bisector. Then the other part that they want is they want us to figure out how long segment AB is. figure out how long segment AB is, first thing we gotta do is set up an equation. Well, we know that since these are both, have these tick marks, that these two have to be congruent to each other, they have to be equal, so we set up the equation. 14x minus 13 equals 3x minus 5. We're not adding them together this time, we're just setting them equal to each other. Subtract 3x on both sides, end up with x minus 13 equals a negative 5. Add 13 to both sides, you end up with x equals 8. Once we know x is 8, we can take that and find the AB. AB is the whole thing, so what we're going to do is just plug into one of these two. If I plug in right here, 3 times 8 minus 5, 3 times 8 is 24, minus 5 is 19, so this part is 19. Well, that means this part's 19, and we want to find the whole segment, so we're going to add them together, and we get AB is 38. We look down there, and it's point M, and AB equals 38, and that looks like letter B. Letter B. Number 9, now you really don't need these grids to do most of these problems on this test, but I'll show you on the first one. I might not use them on all the others. One main, if you need to graph it so you can picture it, and it might make it a little easier, that's up to you. But on number 9, if you look at the points and you got that point H that's like 7, negative 8, that means you need a lot of area down, or a lot of spaces down, and a lot of spaces to the right on the X. So I'm actually going to draw my X, or my Y axis way over here, and my X axis up here somewhere maybe, so that I have space. The first one is negative 3, 0, and of course I screwed up. Negative 3, 0. I didn't go over that way quite, over to the right quite far enough. Would be somewhere about in there, and that's point G. And then 7, 1, 2, 3, 4, 5, 6, 7. Negative 8, 1, 2, 3, 4, 5, 6, 7, and of course I didn't go down far enough, so it's actually going to be somewhere in there. We're looking for, and that's H, we're looking for the midpoint of that segment, which is going to fall somewhere in that area. We really don't need the graph, so I stuck them on there just so you could use them if you like to picture it. The main thing we need is the formula for midpoint. Remember, with midpoint, you add the x's together, divide by 2, you add the y's together. Sorry, not a comma there, get rid of that. You add the y's together, divide by 2. So on this one, our x coordinates are negative 3 and 7. Divide that by 2. Our y coordinates are 0 and negative 8. So 0 plus a negative 8. Divide that by 2. Our ordered pair, negative 3 plus 7 is 4. 4 divided by 2 is 2. 0 plus a negative 8 is negative 8. Negative 8 divided by 2 is negative 4. That should be the coordinates of the midpoint. If we look down through here, 2, negative 4 is letter D. So the answer to this one is letter D. On number 10, again, you really don't need to graph, but I've graphed these 2 points with the coordinates that they gave us, and they tell us that this right here is actually the midpoint. So this time we're looking for, if that's the midpoint, we're looking for the other endpoint. So our segment's actually going to run through that midpoint, and our segment's going to come way down in here somewhere, and our other endpoint's going to be way down here somewhere off of my graph. You really don't need all that. What we need to do is set up this equation where we have x for our midpoint, the y for our midpoint, and then we have our formula, which is x plus x divided by 2 and y plus y divided by 2. We have that. This time we actually know these coordinates. Instead of just plugging into this part over here, we're going to have to use both and solve some equations. So this time they tell us m is the midpoint, and the x coordinate of the midpoint is negative 6, and the y coordinate is negative 3. And then they tell us one of the endpoints has an x coordinate that's negative 4. So I'm going to put negative 4 plus x divided by 2. And the y coordinate is positive 4, so 4 plus y divided by 2. And all you're going to do is separate this. You're going to take this part and set it equal to that. So -4 plus x divided by 2 equals -6. And we're going to solve that. We're going to multiply both sides by 2 first. You end up with -12 equals, and then -2's over here just cancel out. You got, or I'm sorry, the 2's over here just cancel out. And you got -4 plus x. Now we're going to add 4 to both sides. And you get the x coordinate of the other endpoint is -8. So the x coordinate of the other endpoint that we're looking for is -8. Then we're going to do the same thing for the y's. We're going to take this right here, the -3, and we're going to set it equal to that y right there. So -3, that's not right at there. Let's come way over here. -3 should equal 4 plus y divided by 2. I turned it around this time, no reason. It doesn't make any difference. Multiply this side by 2, multiply this side by 2, you get -6 equals, the 2's over here cancel out, 4 plus y, subtract 4, you get y equals -10. So the y coordinate here is -10. That should be our answer, -8, -10, and that looks like that's letter C. Letter C. Number 11 says your campsite is located at -410 on a coordinate system, so all it's going to do, it's going to go over this way, -4 and up 10. So that's your campsite. We'll call that C. The next check station is located at -10, -1, so we'll go out this way, -10, -1, that's down here. That's the check station, we'll call it S. And we really don't even need the coordinate system. All we're trying to do is find the distance between these two. Well, to find the distance between those two, use the distance formula. Distance formula again looks like this. Remember, your x's go here in the first part, your y's go here in the second part. Our x's this time are -4 and -10, so -4 minus 10. We're just trying to find the distance between these 2 points. Our y's are 10 and -1. So I do that. This one's going to change the plus there. -4 plus 10 is 6. We got 6 squared. 10, we're going to change this to plus. 10 plus 1 is 11. So we got 11 squared. 6 squared is 36. 11 squared is 121. We add those two together and you get 157. And then you grab your calculator and you take the square root of so you take calculator, take square root of 157, and it's about 12.53 something. I would just leave that number on the calculator, because the next thing we got to do is, they said each part counts as let's say 1.55 miles. So we're going to take this times 1.55. So just leave that number on your calculator, this number right here, and just hit times 1.55. And you get about 19.4, which is letter A on the problem. And this should have been problem 11, not problem 10. This is problem 11, which was 19.4 miles. I wrote down the wrong thing. Number 12. Number 12, they give us this triangle. Well, to find the length of this side over here, AB, and we want to find the perimeter of this triangle. Find the length of this side, all we got to do is count. 1, 2, 3. So that side's 3. Find the length of this side. 1, 2, 3, 4, 5. That side's 5. So we now know that we have at least 8. All right. So if we look at the answers, even if we can't find the length of this side by using the distance formula, which I'm hoping you can, hopefully you could get a better guesstimate as to what your perimeter is. We're going to use the distance formula to find the length of BC or CB. So we're going to use that ordered pair and that ordered pair. If I look at those, my x coordinates are -4 and a 1. My y coordinates are -6 and -3. just do the math here. -4 minus 1 is -5. -5 squared is 25. Here, change that to plus. -6 plus 3 is -3. -3 squared is 9. Add those two together and you get the square root of 34. You grab your calculator and you do the square root of 34. And you get about 5.8. So the length of this side right here is 5.8. Find the perimeter of this, we're just gonna add those three. So 5 plus 3 plus 5.8. And that's gonna give you about 13.8 units. And that's letter C. Problem 13, they want you to find the perimeter of this rectangle that I've already drawn on the graph here. So they want you to find the perimeter of that rectangle. Well, it's nice because all these segments are either horizontal or vertical, so all we gotta do is count. 1, 2, 3, 4, 5. That side's 5. And it says the perimeter of the polygon, but it happens to be a rectangle. 2, 3, 4, 5. That side over there should be 5 also. 1, 2, 3, 4, 5, 6, 7, 8, 9. That side's 9. Well, this side over here is going to be 9 also, and all we do is add all those up. 5 plus 5 is 10. 9 plus 9 is 18. 10 plus 18 is 28. So it's 28 units, and that would be letter D as your answer. Number 14, they want us to find the area of this polygon. We look at this, and I graphed the points here already. And again, if you graph them, that's fine. If you don't have to, then you don't, whatever. If you can tell that they're vertical and horizontal, or you could use the distance formula here. I graphed it just to see that they are all vertical or horizontal segments, and all I gotta do is count. 1, 2, 3, 4. The length of that side is 4. 1, 2, 3, 4, 5, 6, 7. Length of that side 7. Find the area of a rectangle. All we're going to do is length times width or base times height, whichever one you want. So those are the only two numbers we need. We just take 4 times 7 or 7 times 4 and you get 28. And with that, you got to remember that your units are square units. We want square units, and that happens to be answer A. Number 15, they give us this rectangle. And they want us to, it says sandbox, each unit coordinates plane represents 1 foot. Find the area of the sandbox. So again, we're going to use area equals length times width. We're going to use that formula. Now what you got to be careful of on this is when they graph this, you got to know that they counted by 2s, not just 1s. So when we go up here and we count and find that width of that sandbox, it's not going to go 1, 2, it's going to go 2, 4. So that width is 4, and then we go 2, 4, 6, 8. The length is 8. So the width is 4 and the length is 8. So we do 8 times 4, and we get 32. And it's got to be, each one counts as 1 foot, so it's going to be feet squared. If we look down through there, that's letter B, feet squared. 32 feet squared. Number 16. Number 16, they give us this picture, and they tell us that this whole angle, BDA, that's all the way around from here to there, that whole angle is 144 degrees. All we're going to do is set up an equation. This angle plus this angle should equal that whole thing. So 7x plus 34 plus 9x plus 46 should equal 144. I'm going to do quite a bit of this just real quick. That's 16x, 34 and 46 gives us 80. Equals 144. Subtract 80 on both sides. You end up with 16x equals 64. Divide both sides by 16. You end up with x equals 4. They didn't ask us to find x. They actually asked us to find the measure of angle ADC. Measure of angle ADC. So that means we're going to take that 4 right there and plug it back in up there. 9 times 4 plus 46. 9 times 4 is 36. 36 plus 46 is 82 degrees. So the answer should be 82 degrees, which is letter B on the paper. 17, they give us this picture. They tell us this is a right angle. Well, if that's a right angle, then that means these two angles have to be complementary to each other. So we set up our equation, negative 3x plus 20 plus negative 2x plus 55 should equal 90 because they're complementary. They add up to be that right angle. Really didn't need this plus and minus in there. Negative 3x and negative 2x gives us negative 5x. 20 and 55 gives us 75 equals 90. Subtract 75 on both sides and you end up with 15. Divide by negative 5 and you end up with x equals negative 3. They didn't want us to find x, they wanted us to actually find the measure of angle BDC, which is this angle. So we're just going to plug back in right here and we do negative 3 times negative 3 plus 20. Negative 3 times negative 3 is positive 9 plus 20 is 29. So our answer is 29 degrees, which happens to be letter A on the paper. Letter A. Number 18, they tell us that this is a straight angle. So that means these two angles should be supplementary to each other. So we're going to set up the equation, this angle plus this angle should equal 180. I'm going to do some of it in my head and just collect like terms. Negative 7x, negative 8x gives me negative 15x. 12 and 48 gives me 60. All that should total up to 180 because they're supplementary. They add up to be that straight angle. Subtract 60 on both sides, I get negative 15x equals 120. Divide by negative 15. These cancel out and you're left with x equals, grab your calculator probably and do 120 divided by negative 15. And you get 8. So it's negative 8, sorry. We take that. They want us to find the measure of angle BDC, which is this angle. So we're just going to take 8 and plug it back in right there. So negative 7 times negative 8 plus 12. Negative times negative is positive. 7 times 8 is 56. 56 plus 12 is 68 degrees. So our answer here is 68 degrees, which is letter D. Number 19, they tell us that ray RT right here bisects this angle, and they tell us that this angle down at the bottom is 54 degrees. Well, then that means this angle has to be 54 degrees. And we could actually find the whole angle here by adding those two up, which would be 108 degrees. And they actually ask us to find angle SRQ, which is the whole thing, so that's 108 degrees. Remember, bisect means split the angle into two equal parts, same as with the segment bisector. And our answer here would be letter B. Number 20, they tell us angle 1 is 66 degrees. They tell us angle 2 is complementary to angle 1, so all we got to do, subtract that from 90. Since they're complementary, borrow here, and that's 8. That gives you 24, so angle 2 should be 24 degrees, and that is letter A. 21. Problem 21 says angle 3 and angle 4 are supplementary. Measure of angle 3 equals 57 degrees. They want us to find the measure of angle 4. So we just take, since they're supplementary, we take 180 minus 57. Borrow here. That's 3, 2, 123 degrees. So angle 4 is 123 degrees, which is letter B. 22, they want to know, and I didn't draw the forklift or the truck or anything, they want to know what the measure of angle 2 is here, and they tell us that these two are supplementary to each other, and angle 1 is 6 degrees, so all we got to do is take 180 minus 6, which gives you 174 degrees, which happens to be letter C on the paper there. 23 is one of the two angle problems, so what I'm going to do first is write angle 1, angle 2. They tell us that these two form a linear pair, so that tells us that together they add up to 180 degrees, they're supplementary to each other. We're just gonna let angle 1 be x, and then it says the measure of one of the angles is 8 times the measure of the other angle. So if angle 1 is x, angle 2 has to be 8 times that, which is 8x. Then we just set up an equation. X plus 8x, those two add together, should add up to be 180. So that's 9x equals 180. Divide by 9, and you end up with x equals 20. Once we know x is 20, we can go back here and find both angles. That means this angle is going to be 20 degrees. Plug in 20 there. 8 times 20 is 160 degrees. What they ask us to find here? It says, find the measure of the larger angle. Well, 160 is larger than 20, so our answer has to be C. 24. Ignore that. 24. They give you a picture, it looks like this, and this is point E, Q, 8, and T, and then they say which are possible names for it, and we got T, Q, E. Well, that works, so A works. Then we got angle 8. Okay, we can call that angle 8, so B works. EQT, that's this, so EQT, that works, so C works. Then D is all of those, so the answer is D, because all of them work. Those are all ways to name that angle. Okay, problems 25 through 28. First thing I'm going to do on this problem is go through and just find all of these links. Some of them are real easy. There's 2 of them that we actually have to use the distance formula on. This one, 1, 2, 3 for BC, so the length of that is 3. This one going up and down here, 1, 2, 3, 4, so the length of that's 4. Well, the length of this one over here is going to be 4 also. From C to F, 1, 2, 3, 4. From F to E, 1, 2, 3. From E to D, 1, 2. Oops, 2, not 3. Now this CD and, what I do, put the wrong letter in there somewhere. Yeah, this should be an A out here. So CD and AB, we have to actually use the distance formula on. Coordinates for A, we go out 1, 2, 3, 4, and down 1, 2, 3. So -4, -3. Coordinates for B are out 1, -1, and then up 1. Coordinates for C, it might, your paper might be a little bit easier to see than mine. We go out 1, 2, 3. No, I'm sorry, we go out 1, 2, 3, and then up 1. Coordinates for D, we go out 1, 2, 3, 4, 5, and down 1, 2, 3, so -3, and we just got to use the distance formula on those. All right, so let's do AB first, and I'm going to do a lot of this in my head. My x coordinates are -4, -1. Maybe I better write it down. So -4 minus a -1 squared. The y coordinates are 1 and -3, so 1 minus a -3 squared. Change this to plus, change that to plus. -4 plus 1 is -3. -3 squared is +9. 1 plus 3 is 4. 4 squared is 16. Add those two together and you get 25, and the square root of 25 is 5. So this one here actually comes out even, and the length of it is 5. We go over here and we look at this one. I'm going to do the same thing. I'm going to do some of this in my head. We got our x is 5 minus 3 is 2. 2 squared is 4. Our y is -3 minus 1 is -4. -4 squared is 16. 4 plus 16 is 20. 20 is not a perfect square number, so you grab your calculator. Find the square root of 20. It's about 4.5. So length of this segment's about 4.5. Now we can go over here to the right and answer all of the questions. we want the perimeter of triangle ABF. ABF is this triangle. All we're going to do is add up this side, and this side. Well, 4 plus 4 is 8, plus 5 is 13.
Caleb, your door to the office, please.
So the perimeter there is 13 units. We want the area of that same triangle. This is a right angle right here. So this 4 is going to be our height. This 4 is going to be our base. So for area of a triangle, we do area equals 1/2 times base times height. Well, that's 1/2 times 4 times 4. Half of 4 is 2, 2 times 4 is 8, and you gotta remember it's 8 units squared. 8 units squared on that one. Next one, we want the perimeter of BCEF. BCEF is this here in the middle. Well, the perimeter, we just add up all the sides. 3 plus 3 is 6, plus 4 is 10, plus another 4 is 14. So 14 units. To find the area of that same shape, it's a rectangle, so all we do is length times width. Well, the length is 4, the width is 3. It doesn't really matter which one's width and which one's length. So 4 times 3, and we get 12 square units, or units squared, whichever way you want to write it. So 12 units squared on that one. All right, problems 29 through 31. 29 first says, give 2 other names for line WP. Line WP is right here. There's actually several different names we could give it. One of them, if we look right here, we could just call it line D. Line D, that's one possible name. We could just take the WP that they gave us and we could call it line PW, just turn it around, that's another name. You could also call it line NW, line NP, so on, so on, so on. Bunch of different names. Number 30, give 2 other names for plane ANW. Plane ANW, my plane looks spectacular here. That's our plane. Remember, you can name a plane with any 3 letters that are on the plane, or if they happen to give it to you, which this time they do, a letter in the corner. So this one we could name plane O. The other name we could give it, plane, and we just picked 3 other letters other than A, N, W. So maybe we pick DAP. There's a whole bunch of other names you could give it. Number 31 says name 3 points that are collinear. Collinear. So we want 3 points that are on the same line. Well, the easiest ones, N, W, and P. So point N, point W, point P. Then it wants 4 points that are coplanar. Well, any of these that fall in this plane would work. Any of the points. We can't use this D here and we can't use that O there, but we can use any of the other points. So I'm going to use point D, point S, point A, and point W. All those are coplanar. Coplanar means on the same plane, collinear on the same line. Number 32, they want us to graph the 2 segments and determine whether they are congruent or not. And it says be sure to make sure you graph it. When I look at this, I see that I have Y's that are 7 and X's that are 5, and it looks like almost everything's positive except for that one Y. So when I draw this, I'm going to draw my X-axis down a little bit so I can have more space going up for the Y's, and I'm going to draw my Y-axis over this way a little bit because I don't need any negative stuff for the X's. You don't always have to put the X and Y right in the middle of the grid. So 3, 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. That's point R. 6, 7. 1, 2, 3, 4, 5, 6, and up 7. That's right there. That's point S. Then T is 5, 0. 1, 2, 3, 4, 5, 0. It's right there. And U is 5, negative 3. 1, 2, 3, down 3. And they want to know segment RS and segment TU, are they the same lengths? RS is right here. Well, that's nice because all we got to do is count. RS, the length of it is 3. TU, sorry I didn't put my letters on this other one like I should have. That was T, that was U. TU is right here. All we got to do is count 1, 2, 3. So the length of segment TU is 3. So we look at those two. They have the same measures. So that means yes, they are congruent. Yes, they are congruent. So they wanted to see this graph to make sure you know how to graph. Make sure you're doing that right. Make sure you're doing that right. And they wanted to know if you know what congruent means. Problem 33. They say identify the segment bisector of segment AB. This is segment AB. And you'll notice here that they put these tick marks on here to tell you that segment AM and segment MB are congruent. So the segment bisector is whatever splits it there. Different things you could put. You could just put point M, or you could put line NM, or you could even put ray MN. Any of those would work. I'm gonna, since ray MN is the last one I said, that's the bisector. And then they also want to know how long is segment AB. So they want to know what is the distance from here to there. Well, if this part's 48, then that means this part over here has to be 48 because it was split into 2 equal segments. And all we do is add those two together and you get 96. So those are your two answers on 33. 90, and this should be 96 units, whatever the units are. 34 says classify the polygon by the number of sides. So we just count the sides. 1, 2, 3, 4, 5, 6, 7. Looks like it's got 8 sides. Well, if it's got 8 sides, you should remember that then it is called an octagon. And then it also says tell whether it's convex or concave. This one happens to be convex. Remember, concave are the ones where you have a polygon and one of the sides is caved in, like it goes in. The angle inside is more than 180 degrees. 35, they want you to name this angle in 3 different ways. Please make sure you remember your angle symbols. So we have angle. We can name it starting here and going around it that way. L, Y, T. Angle, we could start here and go around this way. And you could name it angle T, Y, L. Or, since there's only one angle in this picture, we could name it with just the vertex letter, which in this case is Y, so angle Y. 36, they want you to name 3 different angles in this picture. So angle Z, E, P, that's one. Angle W, E, P. And then the last one is the whole outside angle, which we'll call angle Z, E, W. Problem 37, they wanted to use the protractor to measure angle ABE. Hardest part here is probably splitting it off, and I've drawn angle ABE without all the other angles on there. You got to remember to look at your angle. This one looks like it's going to be an obtuse angle, so I got to come up with a measure that's more than 90. If I go around this, I'm going to use this set of numbers: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. And then I don't make it all the way to 120, but it looks like I'm just right at halfway. So the answer here would probably be 115 degrees. So measure of angle ABE is about 115 degrees. 38, they want us to find the measure of angle FBE. Well, they didn't line this first side up with 0, but you can still start there. We start there and we go around. That's 10, 20, 30, 40, 50, 60, 70. That doesn't look like we don't get all the way to the next one. So 70, it looks like it's almost exactly halfway, so about 75 degrees. Number 39, it says, when viewed from the side, the spire on top of a building forms a triangle, triangle ABC, with angle B and angle C being congruent to each other. So this angle and this angle are congruent to each other. So that tells us that these two expressions are going to be equal to each other. What is the measure of angle B? Make sure you show your work, it says. So we know that these two are going to be congruent. Now back to the spire thing. Doesn't matter if you know what a spire is or not. It's just like the peak of the house or whatever. You don't have to worry about what a spire actually is, just use the information you're given. So we know that 2x plus 47 should equal 9x plus 33. This time we're not adding them together, we're setting them equal to each other. We get all the x's on one side, so subtract 2x, you end up with 7x on that side, and I'm going through this pretty quickly. Subtract 33 on both sides, and you end up with 14. Divide by 7, you end up with x equals 2. They ask us to find angle B, so we're going to come right back over here, and we're going to plug in 2. 2 times 2 plus 47, 2 times 2 is 4, plus 47 is 51, so angle B would be 51 degrees. Angle C then would also be 51 degrees. They didn't ask us that. And hopefully you have heard in the past at some point that a triangle adds up to 180, the three angles of a triangle. So if this angle is 51, this angle is 51, you could figure out what that angle is. Problem 40 says, name a pair of complementary angles from the picture. Complementary, remember, adds up to 90 degrees. Doesn't matter if they're neighbors or not. All that matters is they add up to 90. Well, I look at this one, and 28 plus 62 does equal 90. So we got to name this angle, which is angle RQD, and you could have named it a different way if you want, but that's the way I named it. And then we want this angle, which is angle PSO. Number 41 says name a pair of supplementary angles. Supplementary means they add up to 180. Well, if I look at these two numbers, 106 and 74, you add those together, they add up to 180. So angle RQZ and angle TSO. And again, there's different ways you could have named those. Had to be with 3 letters though this time. And you had to make sure that the vertex letter, S or Q, was in the middle for each answer. Number 42, name a pair of adjacent angles. Many different answers, or a couple different answers on this one. Adjacent angles just means they share a vertex and a side. So I'm going to just name these two, which is angle PSO and angle OST. 43 says, complete the statement. Angle 12 and angle blank are vertical angles. So angle 12 is right here. What's the vertical angle to it? It'd be angle 10. So the answer to that one's angle 10. 44 says, identify the linear pairs that include angle 13. Angle 13 is right here. We want all the other angles that are a linear pair with angle 13. Well, 12 and 13 make a line together. 13 and 10 make a line together. And those are your two answers, angle 12 and angle 10. Problem 45 says the cities shown on the map lie approximately in a straight line. Find the distance in miles from Denton, that's right here, to Denton, Texas, to Fort Worth, Texas, which is right here. So they tell us this whole distance from here to there is 274 miles. The distance from San Antonio to Fort Worth is 241 miles. And we want to know that distance. All we got to do is take 274. This is using the segment addition postulate. 274 minus 241, actually segment subtraction, but means the same thing. And we get 33 miles. I know you're amazed at my great drawing ability there. 46, a cruise ship leaves port in Naples, Florida. So supposed to be starting here. I got mine a little too far inland, but it leaves from Naples, Florida, en route to Cancun, Mexico. The map shows the ship's position at 3 different points during the cruise. Point N represents Naples, point B represents the approximate position after 5 hours, and point C represents Cancun. So they're saying that it took them 5 hours to get from here to there. 5 hours. So, first thing they want us to do is find the total distance the ship traveled. All we're going to have to do to find this total distance, and again, this one should be out here closer to the shore instead of way in there. All we're going to do is add those two together. So 135 plus 335, and you end up with 0, carry the 1, that's 7, 470 miles. It traveled 470 miles. Then it said the ship's cruise lasted 18 hours. So it took 18 hours to go from here to there. And they want to know, estimate the ship's average speed in miles per hour. So remember, and I gave you a little hint there, rate equals distance times time. That's wrong. Now I wrote that formula wrong. It should be distance equals rate times time. I don't know how I messed that up. So distance equals rate times time. Well, our distance was 470 miles. Our rate we don't know, so that's going to be our variable. And our t is 18 hours. So all you're going to do to solve for the rate, I hope I remember if there's a problem like this on the test to tell you that I wrote the formula wrong. So we get 470, you grab your calculator, 470 divided by 18, and you get about 26.1111, so we'll say about 26 miles per hour, about 26 miles per hour. (47) They wanted you to sketch ray AB and line BC. I'm going to do line BC first. Line BC, we just do this and we put a point on here that's B, put a point on here that's C. Doesn't really matter where it's at. Ignore that. Then we want ray AB. So we want it to start at A and go out through B. Well, it might be something, maybe A's up here and it's a ray that goes out through B that way. So it could look something like that. Again, that's not supposed to be there. Number 48 says sketch a line and array that intersect a plane at the same point. So first thing I'm going to do is draw a plane. And then we want a line and array that intersect at the same point. Well, what you're going to have is you're going to have a line going through the plane. So we'll put a point right here. And we're going to make this line go through the plane by putting some dashes there. And then we're going to have some ray coming out of the plane. Something like that. We could label it. They didn't give you any letters, so it doesn't really make any difference. But both of these, the point or the ray starts right on the plane and goes out this direction. The line starts here and it goes down through the plane. 49, sketch line DE and line MP intersecting at M. So we got two lines, so I'm just going to draw two lines. And that's not supposed to be there. One of them is going to be line DE, so I put line DE. And they say they intersect at M, so I'm going to put point M right there. And P could either go on this end, it could go on the other end of the line. It doesn't make any difference. Bonus one. Sounds like we have something like this. We're taking a trip, and we're going from city A to city B. So we'll just put an A and a B on a segment there. It says you travel from city A to city B and back. So we actually went there and came back. Your trip lasts 4.5 hours. So 4.5 hours. We'll use the decimal this time. And you maintain the speed of 60 miles per hour. So 60 miles per hour. City C, a city you pass on your trip, is 37 miles from city B. So city C is in here somewhere. We don't know where, but we do know it's 37 miles from city B. So we'll put that on there. Find the distance between city A and city C. So we're looking for that distance. Well, what we can do is we can figure out this total distance, because they told us that we traveled for 4.5 hours and we traveled at 60 miles per hour. Well, again, it's, and I'll write it right this time, it's distance equals rate times time. Well, our rate is 60, our time is 4.5 hours. We take our calculator and we multiply that, and that's going to tell us the distance. 4.5 times 60, and we get 270. So we traveled 270 miles. Now you gotta be careful with this, because they said we went there, we went to B, and then came back. So we have to divide that by 2. So that means the distance from A to B, we only want half of it, is 135 miles. Well, then to find this distance, we take 135, subtract off 37, and you get 98. So the answer to this one is 98 miles. I'm not sure what's going on with my pen, it's going a little crazy. All right, bonus number 4, a little tougher here. You got to be able to imagine this being 3-dimensional. So if you're thinking, if you're looking at this and you're looking at your X and Y axes, your X and Y axes here, it's like that's a flat surface, and the Z axes, so if you're looking at like your desk or something, that's your X and Y axes going through the corners of your desk, and then your Z axis is going straight up and down through your desk. So if you can imagine that's the way my picture here looks, then you can sort of get this idea. A little tough, but use your imagination a little bit. First thing we're going to do on this is we're not just going to go straight to it. Doesn't quite work that way. What we can do is come over here and find some point that's right here, that's directly below this and directly across from this, and we're going to find the coordinates of that point. It's got 3 ordered pairs, and if you're looking at it, we moved to where X is now 6, Y is now 9, but our Z, we didn't go up or down through that Z axis any, so it stays as the -4 right here. And now what we can do is we can actually use the distance formula with those two. We got the distance formula, and you'll notice that your Z's are the same, so they're just going to sort of cancel each other out and be 0. We do -4 minus 6. -4 minus 6 is -10, and we're going to square that, plus, then we do -6 minus 9. -6 minus 9 is -15, and we're going to square that, again, using the distance formula. This is 100. This is 225. We add those together, and we get 325, and we got to find the square root of that. And the square root of 325 is about 18.0. So that means the length of this segment across through here would be about 18.0. This segment we can actually find the length of, because the X's and the Y's are the same, and all we got to do is on the Z axis count how much we go up. So we go from -4 up to 6. Well, that's 10 spaces, so the length of that segment's 10. Well, neither one of those are what we want. We actually want the distance in space from A to B. Well, now what we have here is a right triangle, so we can use Pythagorean's theorem to find the length of this, because we now know this side is 18.0, this side's 10, so Pythagorean's theorem is a squared plus b squared equals c squared. This is our c over here, that's our hypotenuse, so we just do 10 squared plus 18.0 squared equals c squared. Grab your calculator. 10 squared is 100 plus 18.0 squared, whatever that is, it equals, and you get 424 equals c squared. Well, we would just want to take the square root of that then. The square root of 424, again, grab your calculator, is about 20.6. So the distance of this right here is about 20.6, and did they give us any units? System in space by ordered, they didn't really give us any units, so the distance between those 2 points in space is about 20.6 units.